Hey, I'm J.J. Thomson. I'm one of the important people, along with John Dalton, Niels Bohr, and a few others who made a major contribute to the atoms model. I was born in Manchester, United Kingdom, in December 18, 1856, and I will die on August 30th, 1940. I used a tool that was invented by Carl Ferdinand Braun in 1897, originally used as an oscilloscope, which is a machine to show waves, which is called the cathode ray tube. It's used in almost all computer monitors and televisions. It's basically an electron gun. A type of model electrode can send out electrons when it's heated. The cathode is inside a glass tube, and the glass tube is used to pull electrons towards the front of the glass tube, so electrons shoot out in one direction like a ray gun. Electrons hit the front of the tube, where there's a phosphor screen. When the electrons hit the front of the tube, the phosphor will light up. The electrons can be aimed by creating a magnetic field. It controls bits of the phosphor light up, and a bright picture can be made on the front of the vacuum tube. It will change picture 30 times every second, and it will make it look like the picture is moving because the vacuum inside the tube, which is strong enough to hold out air, and the tube must be made out of thick glass. I established for it to occur, and the atom should have the same quantity of both negative and positive charges. Negative charges were named electrons E-. I proposed the first atomic model, which is also described as positively charged sphere, which electrons were inlaid with negative charges. This model is also known as the plum pudding model. My first experiment was to build a cathode ray tube with a metal cylinder on the end. The cylinder had 2 slots in it, leading to electrometers, which could measure small electric charges. I found that out by applying magnetic field across the tube, and there was no activity recorded by the electrometers, and so the charge had been bent away by the magnet. Negative charge and ray were inseparable and intertwined. In my second experiment, I attempted to deflect them with an electric field. I thought the vacuum in the tube was not good enough, so I constructed a slightly different cathode ray tube with fluorescent coating at one and a near perfect vacuum. Halfway down the tube were 2 electric plates, producing positive anode and a negative cathode, which I hoped would deflect the rays. Rays were deflected by electric charge, proving that rays were made up of charged particles carrying negative charges. I still resolved to understand more about the nature of particles. The nature of particles were too small to have mass or charge calculated directly, but I attempted to deduce from the particles that were bent by the electrical currents of varying strengths. I decided upon later and came up with the idea that cathode rays were made out of particles that are emanated from atoms themselves. This is how I contributed to the atoms theory.